clearing the malignancy.
This whole video is going to be on cell membrane fluidity and how macadamia nuts can influence cell membrane fluidity due to their nutrient composition with their monounsaturated fats. Macadamia nuts also have other bioactive compounds. Oleic acid is a dominant fatty acid in macadamia nuts, so 60% of total fat. So MUFAs integrate into phospholipid bilayers, making membranes more fluid and less rigid than saturated fats.
They form rigid
Or
sludge
the
monsters that
MUFAs
block
in
flexibility.
a
Not on my
macadamia
watch.
nuts,
Here's
they
some olive oil
affect
to
the
loosen things up.
fluidity
Vitamin E
of
helps
the
maintain
cell membrane.
fluidity, like a
These
shield against
MUFAs,
rigidity.
they
Fluid membranes, healthy
contribute to
cells.
membrane flexibility, also supporting receptor function on the cell membranes. T cells, immune T cells, they also have their own cell membrane, and on the cell membrane of the T cells have a lot of different receptors with many different immune function, which is beyond the scope of this video. Phytosterols in macadamia nuts, they help prevent, well, at least one way out of many ways. They help
hijacking immune cells. Tumor cells overexpress CD70, which binds to CD27 receptor on T cells. This triggers exhaust T cells lose function due to high cholesterol buildup. But now, a new weapon arrives, targeting CD70 directly. These tomatoes represent therapeutic agents that block C70 signaling. Immune exhaustion reversed. The immune system reacts
to a concentrated in cholesterol that can contribute to CD70 surface expression on the tumor, which is not a good thing. So macadamia nuts, they also help with the phytosterols by competing with the cholesterol. Okay, so phytosterols in macadamia nuts improves cholesterol balance in membranes without making them too stiff. Also, antioxidants, vitamin E and polyphenols in macadamia nuts protects unsaturated fatty acids in membrane from oxidative damage and prevents lipid peroxidation, because these things would otherwise decrease fluidity. Membranes are mainly made of phospholipid bilayers. Their fluidity depends on fatty
Cell
acid
membrane is like a
composition.
river, fluid, flexible,
fats,
alive,
like MUFAs
but
and
saturated
PUFAs
fats make
are
it too
fluid.
rigid. Meet the saturated fat
fats are
sludge
rigid.
monsters.
Time to clean up.
Macadamia nuts
Olive oil
provide
restores
mostly
fluidity.
MUFAs,
Healthy membranes stay
basically
flexible.
enhancing
Vitamin E
membrane
protects against
flexibility.
rigidity.
Macadamia nuts fats, they even affect cardiovascular cells, leading to improved cholesterol transport. That's important because if cholesterol is building up in the arteries, that starts attracting macrophages, especially if the cholesterol is oxidized LDL cholesterol, and then the macrophages attempt to engulf the LDL cholesterol, and then macrophages turn into foam cells, and then that creates more problems because foam cells can release inflammatory cytokines in the heart and attracting even more cholesterol and then making the problem even worse. So macadamia nuts can also be good for the cardiovascular cells because of better lipid handling in membranes. So by stabilizing and protecting the cell membranes from oxidative damage, it enhances overall cell function and metabolic efficiency. Okay, cholesterol temperatures. At low temperatures, it prevents membrane from becoming too rigid. But at high temperatures, it stabilizes and prevents too much fluidity, which isn't good, because if the cell membrane is not fluid enough, that could stop like nutrients from entering in. And now here's where insulin receptors come in, is that they are sensitive to membrane environment. So too rigid membranes, such as high saturated fat, low cholesterol balance, can impair insulin receptor signaling. And then too fluid membranes may disrupt receptor organization, but moderate fluidity is generally beneficial. So that means that the membrane can't be too rigid, but it can't be too fluid either. Like, it has to be just the right fluidity. Phospholipid unsaturation and cholesterol balance directly influences insulin receptor
is essential for cellular
efficiency.
function. Glucose needs GLUT4 to enter cells. GLUT4 transports glucose across the membrane. Hey, here's potassium. Potassium helps regulate insulin and GLUT4 activity. GLUT4 is crucial for glucose uptake.
To the membrane
now
and
you know how it works.
Fat cells. So GLUT4 is a receptor that comes out to take in glucose.
GLUT4
to
is a
grab
key
the glucose out of the cell and pull it into the cell.
Excess sugar binds to proteins
So even
and lipids.
this
These
is affected
AGEs
as well
damage the
by
extracellular
membrane
matrix,
rigidity.
weakening tissue
Membrane
integrity.
rigidity
Hey,
can
I've got
hinder
just the thing. With potassium, glucose
insulin
is
binding
removed from the
that
bloodstream
triggers
safely.
receptor dimerization. So that means that membrane rigidity could prevent receptor binding. Pretty much means that the insulin receptor or the GLUT4 receptor are not really binding to the surface, and therefore they can't do what they need to do. So
high glucose levels lead to glycation when sugar molecules bind to proteins. These reactions form advanced glycation end products, or AGEs. AGEs damage the extracellular matrix, weakening tissue strength. Potassium helps regulate cellular function and supports amino acid stability. Let's go!
Fluid cell membranes and more rigid cell membranes, possibly because of saturated fats. Cholesterol needs a balance, because too high can stiffen membranes, too low can destabilize receptor domains. I'll have to cover in a different video because that sounds interesting. Also, omega-3 and omega-7 fatty acids, which can be found in macadamia nuts, increase fluidity, potentially improving insulin sensitivity, which is pretty much the opposite of diabetes. So that means that foods like macadamia nuts would be great for diabetics. Now, omega-3s could help diabetics because omega-3s improves insulin sensitivity. But there are some studies arising that omega-3s can be problematic, which will have to be for another video. So if diabetics are insulin resistant and they can't take omega-3 because of the issues that come with omega-3, well, that would create a whack-a-mole situation, because they take the omega-3 to supposedly fix the insulin sensitivity, but the omega-3 still comes with issues, and then as a result of fixing one problem, which is insulin resistance, that's going to cause another problem. Okay, so another reason the membrane must be fluid or viscous is because it will determine how easily proteins and lipids move within the membrane. So if the membrane is too rigid, then the proteins and lipids won't move very well. So as for the consequences of that, I'll have to cover that in a different video. I will be doing more research on that. Okay, also, many immune receptors need to aggregate into microdomains or lipid rafts for
cell membrane is like a river, fluid, flexible, alive, but saturated fats make it too rigid. Meet the saturated fat sludge monsters.
Time to clean up.
Olive oil restores fluidity. Healthy membranes stay flexible. Vitamin E protects against rigidity.
Immune function. So possibly high saturated fats or high cholesterol making the cell membrane too rigid is possibly weakening the immune system, because the immune receptors need a fluid membrane environment so that they can effectively signal, because immune receptors, they serve as a signaling hubs. Membrane fluidity affects how receptors interact with antigen ligands. So sounds like an antigen presentation where the APCs train and activate the T cells so that they can fight cancer cells. Too rigid membranes can reduce this signaling efficiency. Also, an endocytosis, which is like immune upregulation, is also affected. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.